Hello, chemistry class. I am going to do a short video to hopefully go through some of these and then you can watch this for review. So our first compound is going to be Br2. So this Br had 7 valence electrons, this Br had 7 valence electrons, and so here that line represents that they are sharing 2, so that this one can have its full octet, and this one can also have its full octet because they share. Whenever I draw these models or make these models, we're only going to pay attention to either the center atom or the number of bonds between those two atoms. So our first one is Br to Br. So I'm going to have 2. Now they do have lone pairs that come out, but those lone pairs, because they're the exact same on both sides, they're not going to change this angle in the middle. So in a straight line between one point and the next is 180 degrees. And we call that linear because it's in a line. Now the first name it gets with the lone pairs. So the lone pairs are the same on both sides, so it's linear. And then if there was no lone pairs, it is still called. All right, let's move on to number 2. This time we have H. The one change I'm going to make is H to F just means that there's 2 different colored dots, which represent the 2 atoms. Here, we're not going to draw those extra lone pairs, but you can see between the 2, it's still 180 degrees. So it will be linear, linear. If we look at number 3, though, and we compare those 2, it's different for 2 reasons. 1, we have 3 atoms, and 2, we have lone pairs on the center atom. And those are going to change the way that it looks. So we have 1 oxygen. I'm going to make my oxygen red. I'm going to make my fluorine yellow. And you're probably wondering why these come down. Well, that is because of VSEPR. It's the valence shell electron pairs repel. So do you see how we have 2 pairs up here? Those pairs are going to come in a different plane. So these go down and they're in this same plane. This lone pair is going to come at you like so. And the other lone pair is going to go away from you like so. And as you can see, now when I lean it, that makes this model 3D. You can see there, it looks like there's 3 points and then this one coming at you. If I turn it, there's points and one coming at you. If I turn it again, a different way, there's 3 points and one coming at you. So this is a completely different shape. This bond angle here is 109.5 degrees. And it's going to get 2 names. One name if you count the lone pairs, because those lone pairs are pushing, right, him up. And he has 2 atoms and 2 lone pairs. 2 atoms and 2 lone pairs. That's 4 total things to the center. We call that tetra. That is with the electrons. And then I'm going to do another one without the electrons, so just with the atoms. So if I take these 2 off and I look at just the atoms, they're all in the same plane, but instead of being straight and linear, they are bent. So here, these look a little bit different because now we have 1, 2, 3 atoms bonded to the center and 1 lone pair. So I'm going to have pink for my chlorine and N for my nitrogen. I'm going to start to build. I'm going to take and put him. And remember, this pair of electrons repels or pushes these down. So these are pushed in the downward direction, and then I'm going to have my lone pair. So because this lone pair exists here, it pushes these atoms down. So now we get this 3D structure. But this, in this orientation, looks a lot like that oxygen did, or the water, excuse me, with this orientation. Because it still has 4 bound to it. So this angle is still 109.5 degrees Celsius because it has 1, 2, 3 atoms in the lone pair. 1, 2, 3 atoms in the lone pair. So it looks like there are 4 things if we include those electrons. So he's still going to be called tetrahedral because that's with the electrons. And the second name is if you didn't include these electrons, what would this look like? You can see that there's 3 at the bottom, so that makes a triangle. And if I turn it sideways, these are at an angle pointing down. So it's not flat in one plane, it's 3D. So we are going to call that trigonal for the 3 at the bottom, and then pyramidal because it's elevated. And that is without the electrons. Next one we're going to look at is sulfur dichloride. So I'm going to build him, and then we're going to compare him to one other one. So we see that there is 1 sulfur, and he is bound to 2 chlorines. And he also has 2 lone pairs. So these chlorines are in one plane, and the 2 lone pairs are going to go in the next plane. So this one's going to come at us, and the next one is going to go away from us this way. So if I take this molecule and I compare it to number 3, they're the exact same because they have 2 atoms, 1 center atom, and 2 lone pairs. 2 atoms, 1 center atom, and 2 lone pairs. So it has 4 things bound to it, 2 atoms, 2 lone pairs. So this angle again is 109.5, called a and that is with the electron. And then the second shape is if you, so I'm going to have pink for my, and you just in for my nitrogen atoms that I'm going to start to build. I'm going to, it doesn't look linear, it looks input him. And that is with electrons or lone pairs. If we move forward at number 6, we have carbon in the center. And we have 4 H's. So I'm going to remember this one of electrons, carbon, repels or pushes these down. And then these are pushed to represent my hydrogen in the downward direction. And then I'm going to have my lone pair. A lot of you guys are not, because build your model like this the first. It pushes, I'm going to draw it like this and 2 down. What we're now we get this is that you can make this 2D drawing through. But this, in this orientation, by making one of them a lot like that oxygen did, or the water, one of them aligned with this orientation. So that means that these 2 are in the same plane, right? bound, and then one would be coming at this angle, and one still 109.5. And what that does is it makes this entire structure 1, 2, 3 atoms in the lone pair, and so those bond angles are still 1. So it looks like there are 4 things. There are 1, 2, 3. So he's still going to be called tetrahedral, which makes this tetrahedral because that's with the electrons. And the second, because there's no lone pairs, if you didn't include these electrons, what would this look like? You can see that there's 3 because at the bottoms. That makes it without. And if I turn it sideways, it's the exact. These are at an angle pointing down. So it's not flat in one plane. It's, if I look at number 8, so we are going to call that trigonal. 7. You see how they all follow that same structure? Or the 3 at the bottom pairs, and then pyramidal. So they would still be tetrahedral because there's 4 things bound to the center atom. And if you take those lone pairs away,